Hello, this is Jens from SecurityValley, and in this video I would like to talk or share with you possible protection strategy against Nmap scans or in general port scans, and some brute force attacks against, for example, the SSH protocol. If you, for example, have a server out there which is connected to the internet, or for example a web server, and I would like to share with you with NetFilter, or how you can apply with, to be more precisely, with iptables, which is just an interface to the NetFilter module, which is a kernel module for the Linux kernel since version 2.6, to harden a little bit your configuration and make the life of, for example, a bot, script kiddie, or possible attacker as hard as possible. Therefore, I would like to share 3 steps here. The first is how we can fight against SSH brute forcing and SSH port detection. After that, we configure with iptables the NetFilter, or let's call it the firewall layer, to allow traffic from port 80 and 443, and therefore the related outgoing traffic to that ports. And the overall strategy is, if a data packet hits a different port than port 80 or 443 or our new SSH port, then we simply drop the data packet and block it at least for 6 minutes. But the configuration parameter is totally up to you. The final, or the total, or an overall final outcome of that configuration can be found here in this GitHub repository from me, where in more script kiddie repository you find a folder called firewall, and here with some notes and some hints and tips and tricks is the final configuration that you can apply to your server to fight back against annoying port scans, bot traffic, whatever. So the first thing what we're gonna do here is to check on our server, which we would like to protect, the IP address, which is this one here, and we have here my attacking machine. And the first thing we're gonna do is fire up a Nmap default scan, which is a SYN scan, against that target, and we see immediately we have discovered here port 22 and port 80. And we can verify on our machines with the netstat and with TCP listen at the port numbers. We see that this one here, port 22 and 80, is exposed over IP version 6 and IP version 4 to the network here, and let's call it for this example the internet here. The first thing we're gonna do, well, what we can do to kind of try to trick most of the scan bots, is by just simply hide or move the default SSH port to a different one. Therefore, you need to add it under etc SSH the SSHD _ config file, and you see here is a port configuration. And for our example, I'm going to change that to 22,223. Right after, we need to restart the SSH daemon. So we can simply use the system CTL therefore. Restart it, exit, and then connect here with an additional parameter back to our machine. Enter the password, and with again verify the exposed ports to the network here. We should see now that the default port has changed, and let's see how does it affect a possible Nmap scan. So let's fire up the Nmap scan again, and we see right after, by just scanning the 1000 default ports here, the SSH port here is gone. But if we simply increase the port range here to scan all possible ports, you will quickly see that we discovered the new open port here. But for surprisingly, most of the boards out there. This is just enough to make their life a little bit harder. So the next thing we gonna do is level up the firewall or the NetFilter package a little bit. So let's gonna first clear that stuff here and see what is our next strategy is. Let's focus here on the brute force SSH detection. So let's say if we receive an SSH connection attempt to our new SSH port, and if we see that someone tries to log in and log in and log in again, at least in the time range for a few seconds, then we're gonna block the next or the future data traffic that came from that IP address. In order to do so, let me clean up the screen here a little bit. We first create a new iptables chain, and let's call it iptables, for example, the blockchain, and we can then verify with iptables L and D that we have new here, a new block, and our specific configuration for this blockchain is that whatever ends up in this chain, it's gonna log to the kernel log, and the data packet will simply drop. So that means no information back to the source of the data packet. So in order to do so, we just say here iptables.i for insert to top of the blockchain. Give it a prefix with log prefix of let's call it iptables block underscore, and give it a log level of 7. You can just discover the man page by your own board, all the different log strategies. We have an unknown option here, which is totally correct, because I have forgotten to simply say that this target of that rule is always the log, which gives us the opportunity or the option to log to the kernel log, and then we append to the bottom of that blockchain the rule that we want to drop everything. So if we with iptables - A and V see now our blockchain, let's make it a little bit bigger here. We see the first rule: if a data packet will forward moved whatever to that blockchain here, we see okay. With that prefix we should see something in the log, and right after logging the package will gonna drop. So let's move that back here, and let's clear it here. And our next configuration is focusing the SSH traffic. So therefore, let's first figure out which network interface is here exposed. So therefore that I have worked with that IP address, I will focus here on ENP0S8 as the network interface, which is crucial, because you can think about you have maybe one network interface which is fully connected to the internet, and we have maybe one network connection for just your internal or a different network, and you maybe want to apply different rules. So keep in mind that we have ENP0S8 here as our target network interface, and the first thing we can instruct here, so let's make that window a little bit more bigger, is we want to add to the iptables for the network interface. Therefore we have the lowercase I, ENP0S8, and we want to append to the input chain if a protocol with type TCP and the destination port, which is our new SSH port, which is this one here, we want to load the state module, and if the state is new, and we also want to have the load the recent module, and with set and with a name of SSH, we simply write the information down that we receive a new connection, and to the recent modules we set the timestamp and the source of that data packet to maybe process it further in the future. So right after we have configured that, we can build on top of that rule another configuration where we simply say, just give me a second, I need to prepare something in the back. So let's move that here, So we can simply reuse most of the rules here. So we have also the state new here, and then we also gonna load the recent module, and this time we're gonna update the possible entry that we have first discovered with that new policy here, and then we apply the second configuration here, and let's say for our example we want to have 10 seconds here as a bun time, and let's say right after 3 connection attempts in 10 seconds, also affecting the SSH table, we gonna use the air source, and then we forward the traffic to our blockchain, which we have created a few moments ago. So if we simply apply that to IP tables and just inspecting our current configuration rules here, you see, and always the order is important. So the first thing is we just say, okay, if we receive a connection with a state new to this specific port, then in our recent module we write simply down, okay, at this timestamp we have from this IP address a connection attempt against this port. So if this is not the case, then, or right after, okay, if we receive here a new connection which affects the same data packet, then we update the timestamp and the IP address in that SSH table. And if we're facing a hit count of 3 in 10 seconds, then we're gonna block the future incoming connection attempts from this source again for 10 seconds. So, and we can simply try that by just say from this specific machine we want to connect against the new discovered SSH port, this one here, and yeah, we trust the port and just enter a wrong password here, and wait a few seconds again, and do it again and do it again. So right after, we should now, seeing that we run in kind of a connection timeout, or at least we need to wait 10 seconds. And on the firewall side, we can now see, if we make it a little bit bigger here, that we have 4 data packets here forwarded to our blockchain, and therefore dropped the traffic. And we can simply insert or inspect the kernel log, Let me quickly see what was the current command. Yeah, with the journal CDL. Maybe I need to write that correctly. Journal CTL. Minus K for kernel, minus, I think, yeah, we can use F to follow along. And we want to grab something that starts with iptables block underscore, which is the thing we have defined here. And we see we have blocked from this source address login attempts or connection attempts against SSH. So this is simply straightforward configuration. You can decide for your needs if 10 seconds is enough. So I usually have 360 seconds as a default runtime. I've seen sometimes people using 24 hours or whatever. The thing is, with additional commands, you can go forward and can filter that log files for all the IP addresses. Then you can use things like word count or other small Linux tools and create simply weekly IP blacklists, for example. So this should match our SSH brute force protection strategy. And last but not least, we need to talk about the configuration of all the other data packets, or in general try to protect against the diff or a port scan attempt. So therefore we gonna create a rule, and this is a huge rule. So let's clear that here. Let's increase the window a little bit. Let's prepare here something. So again, we use here the iptables commands, and don't forget our network interface, which is enp0s8. Then we append to the input chain, and if we have a TCP data packet, we want to load the TCP module, and we also load the module multiport, which is easier to write. And then we simply negate the command here afterwards, where we say if something is not port 80 or 443. I think in this specific case we can simply skip that, because I've not set up a TLS listener and our new SSH port. And then we use the similar configuration that we've used for the SSH protection. We'll give it a name of port scan, and then we write it to the reasons module. So that means if a data packet it's different port than port 80 or our SSH port, we then just write it to the reasons module. Upon or based on that rule, again, don't forget here to use the proper network interface. We append also to the input chain, and we load the recent module. Also load the name or the recent module table port scan. Use the R check here, and then let's also apply here seconds, maybe 30 for the demonstration here. And we also move it to the blockchain, so to say. So with the iptables list and B option, we see now that the flow from our input chain is first check for the multiport connections. So the first thing is check SSH, and then check all the other things here. Maybe in the future it makes sense to change the order. Yeah, but it's things that I highly recommend to play around a little bit with that. So with that in mind, let's have the journal CTL here up and running, and let's fire up a new port scan against a full port scan against our target here, and see what happened. And you see we're starting here, simply drop a lot of data packets, a lot of data packets. So for example, where we can see the port, yeah, DPT, I think this is the destination port, and you see immediately nmap here. We try to increase, I think, the time period between every data packet is sent for port scan, but for that moment here we kind of out of the game here. And we can simply check here with using curl and try to connect over HTTP to HTTP to our specific target, and you see it's also got block cause the recent module discovers okay, the traffic from that IP address is not allowed anymore. You can, if we look here in the original script that I've written for that configuration, see a lot more improvements, like in general, drop every traffic with invalid packets. So for example, all the XMAS, null, thin scan attempts, and so I think usually these days I think we're totally ignored from the Unix kernel, from the Linux kernel itself. But you can simply add that configuration here. Then you have two rules that protect you against ICMP smurf attacks. And in our case, we should maybe whitelist all the web server traffic and have another configuration for brute force protection for web server, maybe with Cloudflare. There's a CDN in between, or other things like a sync proxy, but it's maybe stuff for another video. Then always a good option to allow the loopback traffic. In this specific case here for our Docker daemon in order to connect, or for the reverse proxy to working. And then have maybe allow the outgoing traffic, and right after, it's always a good kind of best practice right after to drop everything. But this is out of scope for that video. I just wanted to show how you can easily block some port scan attempts here and get on the nerves of the scanner. And I think we were successful in that strategy, or with that strategy. If you like that, find the final configuration here, and again bring back the strategy. I think with just 2-3 simple configuration tricks here, we were successful in our fight against possible script kiddies, bots, whatever. It should protect your web server or your server in the internet. So thanks for watching, and I hope I see you in the next one.